In lesson 8.4 we have a theorem on absolute convergence. It says that if you have a series that's absolutely convergent, then it's convergent. Sounds a little bit silly, but what it means is that if it converges with absolute value, it'll converge without absolute value. So if you have one that's alternating in sign, you might want to take its absolute value and see if it converges. This also helps us with the ratio test. So in homework 21 to 34, it says absolute convergence. It includes doing the ratio test, which we'll show you in a little bit. An example where the absolute convergence comes in handy is in this series that involves a trig function. Cosine of n, this would be in radians, divided by n squared. N goes from 1 to infinity. If we expand a few terms, cosine of 1 over 1 squared, cosine of 2 over 2 squared, cosine of 3, that should be of 2 and of 3, over 3 squared, and so on. What's a bit unusual here is that it doesn't perfectly alternate. 1 radian, the cosine of 1 radian would be positive. The cosine of 2, 3, and 4 all end up negative, and then it switches back to positive. So it's a little bit difficult to decide if this would converge or not, but if we take the absolute value of it and examine what that series does, it's helpful. So we are now examining what this series does. If it converges, then the original without absolute value would converge. If we think about what are our options, the largest the cosine gets is 1. So it seems as if a comparison test would be best. The cosine of the nth over n squared in absolute value has to be smaller or less than or equal to 1 over n squared. Again, because the cosine the biggest it would get is 1. So each term would be smaller than 1 over n squared. We know that the series 1 over n squared is convergent, and therefore by the comparison test, this series is convergent, which by absolute convergence means the one without absolute value is also convergent. So this is a little bit of an unusual example, but more than anything, the absolute value helps us with the ratio test, which I will show you next.